an ordinary square using wage 1 data. So we're given wage 1 data via WhatsApp. So you just open the data, or you can start maybe by just clearing the data that is present. To clear the data that we uploaded for students, you just type clear. So you have clear data. You can also clear the section of the results. But remember, we are saving a what? A log file. So we will not clear anything. So from there, you have file, and then open, and also you just upload the wage 1 data. So it's wage 1. So you can also choose to browse it just to check how the data is presented. You have wage, education, experience. You can just choose to summarize or run around to check the data, the variables that you have. Yes. So that's how we do. But then our main tasks that we're given are to learn an ordinary square. So learning ordinary square, we can choose to say, let's determine how education, experience, and tenure affect wage. Okay? So we type regress, which sort of form of league and wage as our dependent variable, and then you type education, tenure, and experience. So once you type enter, it brings your results there, as you can see. Yes, this is regression. Yeah, so you can see will be an increase in the number of years of education increases education by what? 0.5, and then as you continue, experience the same way, and tenure. So tenure is like
It's a period of time.
period of time. Fixed video. Okay, hope we understand. So tenure is experience.
Tenure refers to the tenure. Okay, a good tenure refers to the holding of an office, position, or property, specifically defining the period of service or a permanent right to that position.
Okay.
Contract. Short contract.
Number still about the word is not
Tenure kwamba.
so I will test. Okay, we should not test. Testing. Okay, so in terms of testing, we can choose to learn. We choose maybe to learn 2 tests. We can choose to learn heteroscedasticity, and also v-test. So to learn heteroscedasticity, after you've done your regression, you just type estate, head test, test. Yeah, you can see it has a p-value of 0. So another hypothesis is what? The data is not heteroscedasticity. Now, if we have a p-value of 0, we prefer to reject the hypothesis, meaning that this data is heteroscedastic.
Heteroscedasticity.
Yeah. So we can also choose to learn VIF test to check for multicollinearity. So estates, estate what? Yeah. So you see, very value. Much value. Is it value information channel? So for my choice, you count is less than 10. Like you have a VI of less than 10, it means there is no multicollinearity. If your count is close to 10, it can be high chances of maybe 0.9, I mean 9, maybe 9.8, no above 5, there will be high chances. But you see in our case, the VI value for all our variables, experience, tenure, and education is below 5. In fact, 1.4 testing for multicollinearity. So the two tests that we have learned it shows that in our what in our testing for elasticity, most our values are around 0.005, and also testing for estate, most our values are around 1 point. I mean, less than 0.05. So yeah, to continue that, learn diagnostic test. Okay, we have run that, and then learn logistic regression and predict birth weights based on age, motherless, and smoking to pregnancy. So the difference between logistic and that, what's the other test? Probit.
Probit.
I just choose the probability of that event occurring. It shows you the latent, or I should say chance. I don't know.
Chance.
How is the chance?
Chance and probability.
It's quite the same.
So far, okay.
Probit, come on, there's the word latent. I don't know what latent in terms of integration.
Okay.
But we can learn logit here just by doing logit. Logit, we do the same analysis: wage, education, experience, and tenure. See? Wait, what's the word? Sorry. So you learn logit, and yes, you type. So it says we should predict the weight. Is it the weight, the birth weight of the mother? Is what the question? Regression predict birth weight based on age of the mother, less and smoking. So in terms of birth weight, how are we gonna? Which one is birth weight here? LOW. So we type that one, and then we continue. Age, we have one less and small. So from there, yeah. So yeah, we see our results here. We can just see from age, it shows with a mother with a decreased age or a lesser age, has maybe a less chance, like decreasing the mother's age or the mother's weight, I should say, has a less chance of the mother having what a birth weight of 0.030. So into percentage wise, you can say okay, 3%. Yeah. So we also learn what's the other one? We also learn calculate marginal effect. So marginal effect. How are we calculating marginal effect? Is it margin, comma, and then divide dx,
Bracket.
and then star. So this is for all the variables. So if you click enter, it will show you the marginal effect.
And you said if you want to do for a specific variable instead of the star,
just put and put, let's say here age. So we just bring it for age. Yeah. So we also learn probit, which is the last doing we are here for. So probit, the question says learn a probit model to predict following based on. So we're using a new dataset called AutoUse. So we already downloaded this and saved it. So we just upload it, then learn the probit. So it predict following based on weight and what? MPG, which is mileage. So we upload our new dataset, which is auto dataset, and then from there we just learn probit. Probit predicting fallen based on what? Weight. Is it weight? Weight and MPG and what? Weight. Yeah. So you can see this is the result. Yeah, so that's how we we conduct our starter assignment. analysis using Stata. So remember we opened a log file at the beginning of the session. So we also have to close it. So closing a log file is as simple as just typing log close. That's all. Because we have a log file saved. So we can clear out the results. And yeah, and then we can clean sheet. Yeah, so my name is Imonikwala.
My name is Rebecca Mwangode. Mimi Testima.
William Tau. Kenneth Jawinga. Mbugani na
Edmund Ban. Thokozani Beki.
Theophilus Jambo.
Duncan Shera.
So this was our basic video. That is using what? Stata.